We have 57 participants right now, sir. So we can start up with these people. And good morning, dear all participants. This is Akshita Jain, Assistant Manager, Training and Development, IWMA, and your host for the day. On behalf of our IWMA office bearers, executive members, speakers, and senior manager, I welcome you all for our 24th webinar session on sustainable industrial wastewater treatment. Dear all participants, I would like to welcome our Honorable Chairman, Mr. K. Bhaskaran, to give us a welcome address. Mr. K. Bhaskaran has served as an executive member and presently the chairman of IWMA. He is also holding a position of secretary in Kakalur Industrial Estate Manufacturing Association and also A6 District Chairperson for E-Waste Management in Lions Club. Our chairman is the CEO of RT Industries Electroplating Unit located at Ambattur, Kakalur as well as Padapai. Now I welcome our chairman on behalf of all our participants as well as speakers, sir. I welcome you, sir.
Thank you, Shraddha. Good morning to you all. Good morning to Mr. Sujay Elangovan, sir. I welcome you for this our 24th webinar of Industrial Waste Management Association being conducting from this COVID time. For the good morning, sir. And it is a wonderful session, sir, because today we got more than 200 participants registered as of now. So maybe as of now 60 as they joined. Maybe later on they will join also. And I also welcome Mr. our Joint Secretary, Mr. Thirinjanam, sir. And on behalf of IWMA, I also welcome our participants because you are giving a very good support to this our webinars. Because we have been planning weekly basis, weekly Saturdays actually. If any leave comes only, we are skipping it. Otherwise, we have been conducting regularly. So with your support, we have been doing this program. So we want to take this kind of programs. See, today's topic is sustainable industrial wastewater treatment. So Sir has got a very good experience, and he's also from London King Institute. He studied in postgraduate also. He's a very good experienced person. Maybe we can take the technical inputs from him. Later on, if you want a business things, and you can contact him directly for the through IWMA also willing to help us, because we want to come out of the recent technologies in wastewater treatment technology. Because I am also from the electroplating industry, small scale industry, so I am also doing wastewater treatment. So I wanted to implement in latest technology, whatever we wanted to implement the same also. Because one example I can tell you, one of the industry, they were using this kind of technology, and after the treatment, the waste will go to the landfill. But we have got a very good solution with the help of CLRI. Thanks to CLRI, that wastewater has been converted into co-processing raw material. So that is a technology is available, because a lot of scientists are day by day they are coming and asking us. See, recently I got in just day before yesterday only, I met one of the professor called Sri Ramachandra Medical University, Mr. Shankar. He was telling me that in world #2 scientist is from Ramachandra Medical College. See this. They are willing to come, and they are ready to participate with the IWMA, because I think Monday or Tuesday I'm going to sign up with the MOU. So for the industries, please make use of them, because world #2 scientist is coming to us, and they are willing to give some any lecture or any kind of thing. Even they are ready to come to our industry also. If you are having industries, you want to take a class for the industry members, maybe next week also we are arranging for Wheels India for 15 people in-house training. So that is also possible. Apart from this COVID, this webinar, we can follow the COVID norms, and we can participate at your place with very nominal cost. We don't charge cost and all. In fact, because that all we are an NGO, so we want the solution. from the environment related activities. That is why we are coming to you again and again. Why we were been quoting this, one of the industry has been converted into instead of landfill, because we don't want any landfill activities. Actually, IWMA is started with the landfill activities only, because thanks to government of Tamil Nadu only given this, based on the Supreme Court order, and SIPCOT has given a land 32 acres. The 2002, actually 18 years back, we got this land 32 acres to landfill activities only. But our service provider, TNWML, is taking care of it, and we are monitoring them. Apart from we, and IIT Madras is also monitoring them. It is scientific manner we are doing that landfill activity. Apart from that, we have incineration facility also. So that is also monitored by IIT Madras, and we also do some audit monthly ones. Our site is in Gumbudi-Pundi. Based on our past experiences, and now Bargur, recently we got land. And in fact, CTE got last week only. Just 2 days back, we got a CTE for Bargur operations. Another one more site is going to come up in Bargur, because we are going to divide in the Tamil Nadu for 3 to 4 bifurcation, because the transport cost can be saved. Instead of on the way from Coimbatore, it is coming to Chennai, the transport cost will be high. And emission, you can see the emission level, because the lorry is, they're traveling with the lorry, and again emission level will be high. So that can be controlled. That is why government is also supporting us, and they are giving land to nearby Bargur, and we also have an Madurai. Our service provider is having the Madurai, and we are also got one more land in Thoothukudi. Thoothukudi, maybe because of some crisis and other things, we have been keeping it in pending. Maybe next year, I think we will take up with the Thoothukudi projects. So that again, it is all landfill activities. But what we are saying is, we don't want any landfill activities. Instead of landfill activities, if you implement these kind of wastewater treatment technologies, maybe that can be reduced. See, everything will not happen in a day. It will happen if you go by step. That is possible. That is why we are bringing these kind of expertise from outsiders, because they got a very good very good experience, and practical experience is also there. If you want, they can show the live on their one or two industries they are running. So that is possible. That is why we are bringing to 1 hour program today. It is a 1 hour program, detailed. If you want, we detailed. We can discuss with us, and you can also discuss with me directly to Mr. Sujay Elangovan sir, and we are ready to help with any way, both the way, like industry and this company, Mr. Elangovan sir. We can both together sit and discuss one point also. That is possible, because we have an office in Coimbatore. We have a technical team also. We have a technical team for one senior manager is there, Mr. Saravanan. He is leading that daily activities and office. And we have even doctorate people also in our office. Apart from this, a lot of scientists are coming from outside. Lot of universities are coming from outside. Example, I had a very good discussion with Dr. MGR Medical University in Madurai. They are also professors. A lot of professors are there. So they are also ready to come to us, and they give me some problem. We will try to give some solutions. See, we can give 10 problems. At least we will get one problem get solved. So that is good, no? And in fact, we have been working with IIT Madras also. We have been working with the PhD technology for Coimbatore. So like that, we have various colleges from across Tamil Nadu, because we stick on to Tamil Nadu only. Because for Tamil Nadu industries only, I can help you out, because Industrial Waste Management Association was formed for that only. And our office bearers, our vice chairman, Mr. Jagannathan sir, is also running a textile industry. He's from Erode. So he's also willing to cooperate. And our secretary, Mr. Pallichami, he's also from Erode, or not textile. He's also running an industry. And our treasurer, Mr. Suresh Kumar. In fact, he is running a industry and with a zero liquid discharge system, almost fast 10 years. And everything is controlled by CPCB. They are monitoring through Tamil Nadu Pollution Control Board, as well as it has been connected with the CPCB. So the live program, I have seen this, the factory, because the zero liquid discharge system they are following for textile industry. So if you want industries, so that kind of experienced person are ready to cooperate. Even our joint secretary, Mr. Thirinjanam, is also there. So maybe he will give you the share experience. And we have a 13-member executive committees also, the members. They are also from a different industry. So they are also willing to participate with you for any kind of technical details. They will help you out. Apart from this, we are also having but for the students level motivate. This year we don't have this students level competitions. Actually, we are conducting students level competition from 5th to 12th students, school students. So we give them as related to environment. So they are giving, they are coming to IIT Madras and giving the live programs. So it is not a Google it and they are presenting it. See, last year we in fact we have gone to Coimbatore. In Coimbatore, we had a very good, fantastic people. They are also first time we went to Coimbatore, we got a very good response. So from them we selected and we praise them, we appraise them. And the next level, recently we have gone to the other universities. Once if a plus two students is going to give the live presentations, we will give it to some institutions. Institution will take it to the next level. Maybe they will honor them. Maybe I think today also I've read on a newspaper that iron box made by solar. It's a very good thing. So such a things are coming out from the students. So we want to create awareness among the students. So that is the activity we are doing. Even college level also we did, and for southern region, 424 colleges we did one program for called Carbon Zero Challenge with the help of IIT Madras, IWMA, Polaris, that is a IT company, and US consulate. So they are also supported us. We four of them get into this kind of programs, Carbon Zero Challenge. And one of the program was gone to the prime minister level, and he got a very good scope for startup. So even waste can be converted into resources. So that is a very good scope is there. See, cement industry nowadays, they are taking all kind of waste. Only thing is segregate and we have to give it to them. And whatever the way they need, they are taking it in two manners. One is for incineration purpose, another one is for as a raw material. So both the way they are taking. That is why I told you in the initial itself, now we don't want any waste to be come into us and for landfill. Instead of landfill, it is going to 25%. It has come down. 25% now the cement industry is taking care of all the waste. So thanks to all the cement industries, because cement industries are taking nowadays very good initiatives, accepting the wastes. So that is also one thing is happening, and they got a target also. Instead of 25, they want to this year they want to go for 25 to 35. So 35% of the waste is they are going to take care. Then what will happen for our landfill side? Because we don't want to promote landfill side, we want to reduce. That is why today also we bought our one of our speaker. Like that, we want to do lot of activities for the environment related. For the industry, once again, I am telling you, when apart from this webinar, you can also fix with your industry members or any related one-day program or half-a-day program. We are willing to come. In fact, last 2 years back, we went to Thuthukudi also one time. One of the industry, they called me for one 50%. They need some one-day training on environment related. We have arranged the program. That is also possible. It is with the nominal cost. It will be, we won't charge again and again. I'm telling you, we won't charge any single price from you. That is apart from whatever the actual expenses only. So from the Chennai, we are very close to you. So it is very easy, accessible. Our technical training assistant manager Akshada is there. Maybe we can call her. She will coordinate and arrange for the in-house programs. And we are also having in-house program 30 member capacity seat, but it is not as of now. We are not planned in in-house because of the COVID. We have stopped it. We are planning to do that in January or February, after January or February, with minimum people 15. So if you don't have space, maybe that is also possible. So you can come to our place in Coimbatore, near Western only. So there also very good infrastructure we have. So that also we charge very nominal only rent, because everything is from industry only. We have formed. In fact, I am also working with last 10 years from this association. I joined as an executive committee member and joint secretary. Then I became a chairman. In fact, this founder chairman was Mr. Mani, because we have to thank Mr. Mani also, because he only founded, and from 2002 they were having only 7-member industries. Now see this, now 3,100 industries across the Tamil Nadu has got very good strength. Industrial Waste Management Association have got a very good strength. Means 18 years old association, as well as 3,100 industry members as of now, member of the this association. So with your support only, we have been doing. It is a NGO only, because I am. It's a part of it only. I'm doing it, because I run a electroplating unit in 3 places. So that is my major business. But still, I want to focus to this environment related. That is why I am in this field for almost 10 years. This year we have got an election. Maybe after election we will come to know. That is our internal thing. And for the industries, please do come for any kind of activities. Our team will help you out. Thanks for support. Thank you once again. Over to Akshita.
Thank you, sir, for the brief note. Yeah, now I just want to show the disclaimer slide for you people. At periodic intervals, IWMA organizes vendor suppliers to make presentation on their products and services for the benefit of our member industry. However, IWMA does not validate or verify the claims made by the vendors and suppliers. Further, IWMA has a policy does not recommend any specific vendor, maybe vendor A or B, and we request IWMA member to recommend IWMA member industry to carry out their own independent additional verification if they wish to engage with any of these vendors and suppliers. And now, without any further ado, I take a pleasure of introducing our speaker, Mr. Sujay Elangovan, co-founder of Biznustek Systems Private Limited. Mr. Sujay Elangovan completed his master degree in robotics from King's College London. He is a co-founder of Biznustek Systems Private Limited, which specializes in designing and manufacturing of industrial process water treatment system with focus on developing sustainable and cost-effective systems. Biznustek System Private Limited has won several awards such as IMARC for the good design, CII Startup Award, etc., and many other patents. It's a great pleasure to welcome you, Sujay sir. I wish you to take over the session.
Yeah, thank you, Akshita, for the introduction. Good morning, everybody. Thanks for the opportunity given by IWMA. I hope everybody is staying safe during these COVID times, and thank you for making it to the webinar once again. As Mr. Bhaskar sir was telling, sustainability is one important factor in the current scenario for waste management. And this webinar is more of a knowledge and experience sharing session on the above subject. We have experience of over 100 plus pilot trials and around 20 plus installation in the last 2.5 years with various industries. And I'm quite excited to share the experiences with you all. I will have a question and answer session at the end, which will help me address some of the issues and listen from the people present here. So let me start sharing my screen and let's get into the subject. So the agenda for this session is understand what sustainability is all about, understand the importance of zero liquid discharge, the importance of having the right equipment for sustainable industrial wastewater treatment, and how Industry 4.0 is helping shape up the industrial water treatment and its sustainability goals. And I want to share some case studies where we have industry experience in installing these systems and getting the results out. So I'll start. So I would personally like to define sustainability as the ability to exist constantly. So the world is changing rapidly, and there are different sorts of pressures such as population change, finances, climate change, etc. These changes costs an increase in demand for the natural resources, and that is the reason sustainability is very vital. The other definition is sustainability is a process of living within the limits of available physical, natural, and social resources in ways that allow the living systems in which humans are embedded to thrive in perpetuity. So coming back to water, I have some hard facts about water. I'll just state three of them. We all know that less than 2% of the Earth's water supply is fresh water. Of all the Earth's water, 97% is salt water found in oceans and seas. Only 1% of the Earth's water is available for drinking. 2% is frozen. So this makes water sustainability very, very important. So sustainable water management means the ability to meet the water needs of the present without compromising the ability of future generations to do the same. Achieving sustainable water management requires a multidisciplinary and holistic approach in which technical, environmental, economic, landscape, aesthetic, societal, and cultural issues are addressed. So as we can see here, all the factors such as society, economics, environmental put together, the intersection is where we achieve the sustainability, or it's just called the zone of sustainability. So on a global scale, having sustainable water means to provide each person on the planet with affordable access to a minimum of 20 to 50 liters of daily water required to sustain life. This follows the UN General Assembly recognition of the right to safe and clean drinking water and sanitation as a basic human right that is essential for full enjoyment of life. So now it is up to every industry to maintain a sustainable water balance and to make sure the impact on the world is positive. So as Mr. Bhaskar sir was telling, industrial water treatment is a very, very broad field. No two industries are similar. Likewise, no two industrial process water will be similar. It is well known that there is a constant pressure on industries and research companies to adapt and develop sustainable water treatment practices. Zero liquid discharge is one major positive step helping the industries to achieve sustainable water practices. Let us look into it in more detail. So ZLD, or zero liquid discharge, is basically an engineering approach to water treatment where we recover all the water and the contaminants are reduced to solid waste. These can be resold for value, and as Bhaskar sir was telling, cement industries are doing a good job in taking these contaminants, I mean what we call as contaminants, which might be raw material for them. So while many water treatment processes attempt to maximize recovery of fresh water and minimize waste, ZLD is the most demanding target since the cost and challenges of recovery increase as the wastewater gets more concentrated. The issues are salinity, scaling compounds, and organics. All these increase in concentration, which adds cost associated with managing these wastewater. ZLD is achieved by stringing together water treatment technology that can treat wastewater as the contaminants are concentrated. So there are a number of benefits to target ZLD for an industrial process. So there are lowered waste volumes, decrease the costs associated with waste management, recycle water on site, lowering water acquisition cost and risk. Recycling on site can also result in less treatment needs versus treating to meet stringent environmental discharge norms. Reduce trucks associated with off-site wastewater disposal and their associated greenhouse gas impact and community road incident risk. Improved environmental performance and regulatory risk profile for future permitting. Some processes may recover valuable resources. For example, ammonium sulfate fertilizer or sodium chloride salt can be recovered for ice melting, and this can be sold off to industries for value. Several methods of waste management are classified as zero liquid discharge, despite using different boundaries to define the point where discharge occurs. Usually a facility or site property line that houses the industrial process is considered the border or boundary condition where the wastewater must be treated, recycled, and converted to solids for disposal to achieve zero liquid discharge. Why ZLD is important for water sustainability? In a world where fresh water is an increasingly valuable resource, industrial process threaten its availability on two fronts unless the water is treated. Many industrial processes require water and then reduce the availability of water for the environment, or other processes, or alternately contaminate and release water that damages the local environment. So that is the reason we need to adapt ZLD. India has been leading the drive for zero liquid discharge regulation in the last decade. Due to heavy contamination of numerous important rivers by wastewater, we have created regulations that require zero liquid discharge. Another important reason to consider ZLD is the potential for recovering resources that are present in the wastewater, as discussed. Some organizations target ZLD for their waste because they can sell the solids that are produced or reuse them as part of their industrial processes. In another example, gypsum can be recovered from mine water and flue gas desulfurization wastewater, which can be sold to use in drywall manufacturing. Regardless of the organization's motivation to target ZLD, achieving it demonstrates good economics, corporate responsibility, and environmental stewardship. By operating an in-house ZLD plant, disposal costs can be reduced, more water is reused, and fewer greenhouse gases are produced by off-site trucking, which minimizes the impact on the local ecosystems and the climate. So preparing for zero liquid discharge, the first step is to reduce the process water consumption during the process itself. And if there is a way to, so the process has to be studied, and if there is a way to reduce the water at the process site, yes, it has to be reduced. And then trying to reuse the process water then and there at site. And the third step only should be recycling of water, which ZLD, where ZLD must be adapted. So I will next talk about the right equipment for sustainable industrial wastewater treatment, wherein ZLD can be achieved. So equipments are critical for treating industrial process water for achieving ZLD or achieving sustainable industrial wastewater treatment. Their performance is directly linked to how the equipments are operated and maintained. Industries should get the value out of the investment made in procuring the equipment. Technologies such as electricity-based vacuum evaporators, filter press dryers, solar sludge dryers, etc., are currently available for treating industrial wastewater sustainably and efficiently. There is a lot of scope for newer technologies as the air requirements are continuously evolving. We need to carefully consider what value will the equipment add towards sustainable water treatment goals of the organization, and that is why it is important to evaluate them diligently. From our experience, we have put together some important parameters for choosing the equipment for industrial process water treatment. I will run through the parameters and explain them one by one. So first thing which we should consider is the technology used. So what is the technology all about? So if you're buying an equipment, what is the technology that the equipment is basically operating or using to operate? And next, we should understand the major components of the system that gives the overall validation of how the system will work, or whether it is really designed to work in a way it is meant to work. And third thing is, what will be the system input and its output? Will the output be consistent even if the input varies? If yes, what will be the range? Will the output generate sludge or slurry? If yes, how it can be handled? Can it be resold, or can it be disposed of at a lower cost, or can it be resold at a lower cost? The fourth important thing is the reliability of the equipment. Here is where we need to inquire about the wear and tear parts. We need to get these critical spares part list. How soon will the system be up if there is a major breakdown? So we need to rate the reliability depending on what parts go into the system. The most important thing, the next most important thing is the safety of the equipment. We should try and understand what is the level of safety adapted in the equipment. The next important thing is the level of automation in the equipment. How easy is the system to operate, considering our manpower demands and our production demands? That is left to the particular industry to evaluate it, but the level of automation is quite critical for treating the wastewater. The next important factor is the space required. So will the equipment require a lot of space? Am I not using the space properly or in a constructive way, or will it require less space? The next major requirement is the power. So when it comes to the power, the source of power is very important. Electricity is preferred first because when it is generated from renewable sources, due to its low carbon footprint, there is naturally sustainability which is achieved. Avoiding fossil fuel sources is a good sustainability practice. And auxiliary power source, if required, must be inquired. In some cases, electricity will be the main power source, and the equipment might require some sort of steam to operate or start its operation. So all these details must be inquired. Requirement of other utilities such as compressed air, and that must be inquired. If yes, we must understand why the compressed air is used for. Sometimes compressed air is used only for the process, sometimes it is used only for the control. So depending on the system, we have to get the requirement. The most important thing is the cleaning of the system. How will the equipment ensure that it is ready for operation day in and day out? So scaling is one major issue when it comes to sustainable water treatment, and it impacts the efficiency of the equipment directly. It is very important to know how the equipment is devoid of scale formation and is available always. And the next factor is the regulatory body approvals required. So let's say we are putting in an equipment, we need to understand what approvals are required from the regulatory body to make sure the equipment is operational, or you get the permission to operate it. The next thing is the operational cost. So a detailed operational cost, right from the energy, right from any other consumables, has to be asked for. And the last most important thing these days is the equipment should be industry 4.0 ready. The reason is I will carry this discussion in the next topic. So we need to monitor what the equipment is doing as well. It is an asset. So further, the industry should ask the vendor for trials and pilot to check the efficacy of the equipment, because each wastewater is different and you need to really understand this, whether the equipment is the right one for you. So that a pilot or a trials should answer that question. So importance of industry 4.0 industrial wastewater treatment. Not only in the industrial wastewater treatment, water treatment in general needs to be monitored to make sure we are heading towards our sustainability goals. If not monitored, we don't have a feedback on the path taken to achieve our sustainability goals. So I'll start with the components of the industry 4.0. So there are 6 major technological elements of industry 4.0. The integration and embedding of these elements into interoperable production system has the promise to link global value chains, making the world more flexible, responsive, and productive. So first thing is the IIoT, the interconnection via the Internet of Instrumentation and connected sensors and other devices to machinery and vehicles, enabling them to send and receive data. IoT brings the power of the internet, data processing, analytics to real-world objects used in the water utility sector. The next segment is the cyber physical systems, the basic technology platform for IoT and therefore the main enabler to connect physical machines that were previously disconnected. Cyber physical systems integrates the dynamics of the physical process with those of software and communication, providing abstractions in modeling, design, analysis technique. Third thing is the cloud computing. With cloud computing, IT services and resources can be uploaded to and retrieved from the internet as opposed to direct connection to a server. Files can be kept on the cloud-based storage system rather than on local storage devices. So information is available anytime for access. Edge computing, a distributed computing paradigm. Edge computing brings computer data storage closer to the location where it is required. In contrast to the cloud computing, edge computing refers to an decentralized data processing at the edge of the network. The IIoT requires more of a edge plus cloud architecture rather than one based purely on centralized cloud in order to transform products and services in the industrial world. This edge computing will have a computing before it can push data to the cloud, which will reduce the load on the cloud processing or the cloud computer. Next step is the big data analytics. Here is where we are examining the large data and varied data sets for analysis and reporting. So the next function of the next component is the artificial intelligence and the machine learning. Artificial intelligence is a field within computer science in which intelligent machines function like humans, technically speaking. Generally, there are 6 branches of artificial intelligence: natural language processing, machine learning, robotics, vision, expert systems, and planning observation. Machine learning involves the use of algorithms by computers to automatically learn and improve from experience without being explicitly programmed. So AI and ML are more of futuristic prediction technologies where we can say what happens to the wastewater, when will the equipment require a scheduled breakdown or scheduled maintenance, or when might the equipment break down, what is the level of scaling. So all those information is captured in the AI ML segment. So now, why is Industry 4.0 important to water treatment? It is important to manage our asset. Water treatment equipments are costly assets and they need to be managed for optimal utilization. Operating costs are skyrocketing as assets frequently break down and demand immediate emergency repairs. A small unknown change in the incoming process water is enough to disrupt day-to-day operation. In addition, asset management practices are antiquated compared to other industries like oil and gas, chemicals, and even electrical utilities. There is a climate risk as well. The first 3 industrial revolutions transformed our modern society with steam engine, the age of science and mass production, and the rise of digital technology. The world around us has fundamentally changed. Consequently, so did the planet. It has been heating up. As a result, the Earth's climate is changing, and this change is imposing a risk on the environmental, economic, and social aspects of human civilization, challenging the society to find new ways to live and a way that is more resilient and sustainable. And there is always a risk of emerging contaminants such as microplastics and other refractory compounds, which have been detected in drinking water sources, sewage, and wastewater sludge. So these contaminants are harmful to humans and aquatic life. We need to monitor them. So that is the reason Industry 4.0 is important. So in this, we can see there is an equipment which is connected to the gateway, which pumps the information to the cloud, and where it is remote monitored or analyzed, and that can be seen through your smart devices, phone or tablet maybe. So for the water industry to thrive, not just survive, it's imperative to embrace Industry 4.0 and modernize its systems. This means full digitalization of all operations, integrations of not only systems, but people and processes to achieve full digitalization. It also means the deployment of key technological elements of Industry 4.0 to create an interoperable water management network that uses near real-time data and analytics to provide actionable insights to operators. When we talk about important case studies of some of the industrial process water treatment, where we have experience. So this section is directly from our experience testing and interaction with the relevant industries. So the first thing we're going to talk about is spent coolant treatment. So in metal manufacturing and metal processing, a wide variety of processes, example, metal cutting, surface processing, and forming are required to achieve high quality product. Water is an indispensable ingredient in many of these processes. Depending on the process, it can contain a whole variety of materials and substances. The metal cutting or grinding coolant, usually mixed with water in the ratio of 1:19 or 1:20, is taken for this case study purpose. So the traditional treatment for spent coolant. So I'm doing an analysis against the sustainable treatment and the traditional treatment. So the traditional treatment of spent coolant starts with an oil trap, which consists of skimmers to remove floating oil. Then it is pumped to an equalization tank where lime, alum, polyelectrolyte are added. This enters a mixer and flocculation chamber where the sludge is settled, and then pumped out to the sludge drying bed. The supernatant water will have the COD load, which needs to be removed now. It is now fed for oxidation process where sludge is settled at the bottom. The water is then passed through a pressure sand filter and activated carbon filter. After this, it is passed through a UFRO. The RO permeate is used back in the process. The RO reject is fed into an evaporator to recover water. The recovered water is used for process. The slurry of evaporator is further crystallized and collected as salts. These salts are disposed of for landfills or resold if they have value. So now I'm going to talk about the sustainable method of treating these coolants. So you can see the used coolant, which has floating oil on top. So the floating oil is removed after skimming. That is the first step. The second step is to feed that to a vacuum distillation process or an evaporation process, which uses electricity. Now we can see the distillate, which comes out of the system, which can be directly used back into the process. Or if required further treatment, we can pass it through a DM plant and then use it back. So this is the residue which is obtained out of the vacuum distillation process. So this residue is oil which has resale value, and this can be sold for the oil resellers, or oil they buy in secondary oils to prepare lubricants and other greases or secondary greases. So these are the observations. So let us take a 20 kL spent coolant system. While using and adapting sustainable treatment method, the size of the plant is reduced by 5 times. The energy consumption is monitored regularly, as it is just an electrical based system. The system is not labor intensive and automated. Zero liquid discharges are achieved. No requirement of a boiler and cooling tower to treat the to achieve ZLD in this case. Next, we'll proceed to phosphating water treatment. Phosphating is a conversion coating applied to steel and iron components. In its basic form, the process involves immersing a component in a dilute solution, which converts the surface of the metal into a layer of microscopic phosphate crystals. The crystalline nature of this coating retains oil and provides a foothold for paint, and so it is most often used as a pre-treatment process. So traditionally, phosphating water treatment, the initial step is to correct the pH, then it is pumped to a coagulation tank. The slurry obtained is pumped to a slurry drying bed or a slurry dryer. The supernatant is fed to a clarifier. The slurry obtained is pumped to the slurry drying bed or a slurry dryer. The supernatant is fed to an equalization tank, then the water is then passed through a pressure sand filter and activated carbon filter. After this, it is passed through UFRO. The RO permeate is used for process. The RO reject is fed into an evaporator, which requires boiling into a cooling tower to recover water. The recovered water is used for process. The slurry of the evaporator is further crystallized and collected as salts. The salts are disposed for landfills or resold depending on the value. So let us see what the smart and sustainable treatment is all about now. So the input feed, whatever we got from the wherever we are treating, is around 1.6 pH and a TDS of around 8,000 ppm. And the first step is to neutralize the pH. And after neutralization, this is how the feed looks. And this feed is filtered to remove suspended particles. And now this is the feed for the evaporation system. And this is the filtration residue which is removed off. It can be disposed of. So after evaporation, we see the TDS of around 190 and a pH in the range of 6.9 to 7.2, which can be used back in the process, or if required, passed through a pressure sand filter, activated carbon, and a DM plant before it can be taken back to the process. So our observations are the systems work only on electricity, and the consumption of chemical is minimal except for the pH correction. Whereas in the previous case, you need a lot of chemicals for coagulation and other process. The energy consumption is also monitored as the system is purely electricity based. The system is cost effective as fewer equipment and treatment steps are involved. The system can be easily monitored for performance. Zero liquid discharge is achieved. So the next case study is about non-destructive testing liquid penetrant water treatment. So liquid penetrant testing involves the application of a fluid with low viscosity to the material to be tested. This fluid seeps into any defects such as cracks or porosity before a developer is applied, which allows the penetrant liquid to seep upwards and create a visible indication of the flaw. Liquid penetrant tests can be conducted using solvent removable penetrants, water washable penetrants, or post emulsifiable penetrants. Traditionally, the industries were disposing of the penetrant water through an authorized agent, as there was no specific method available to treat on site. Evaporation is the technology to treat this, but the traditional evaporators were very costly, as the quantity generated wouldn't be greater than 5 KLD or 5,000 liters a day, and will require boiler and cooling tower. Now we have energy efficient, compact, and electricity based vacuum evaporators, which can treat processed water from 0.25 KLD itself. The liquid penetrant is directly fed into the energy efficient electricity based vacuum evaporator where the penetrant is treated. The water obtained is then passed through a pressure sand filter and activated carbon filter and reused. If the quality has to be enhanced, it has to pass through a DM plant. The residue obtained in this case is oil, which has a resale value. So here we can see the distillate after vacuum evaporation, which can be reused back in the process directly. This is after carbon filtration, nothing changes. And this is the residue obtained, which can be disposed of, as since it has resale value. So the last case study for today is the RO reject water treatment. The traditional RO reject water treatment is to feed the reject into an evaporator, which requires boiler and cooling tower to recover water. The recovered water is used for the process directly. The slurry of the evaporator is further crystallized using agitated thin film dryers and collected as salts. If salts are valued, they can be resold or they're disposed of in the landfill. So This is the air reject obtained, which can be fed into the electricity-based vacuum evaporators. The distillate is obtained after vacuum evaporation. These are the residues obtained. So this residue is further dried using a filter press dryer or a solar sludge dryer, depending on the client's requirement, and then we can obtain the salts, which can be reused or disposed of. So there is no requirement of boilers and cooling towers in the sustainable method. Energy source is just purely electricity. So the running cost per KL is 400 rupees when compared to 1,500 rupees in the traditional method. And there is low carbon footprint, since the electricity is the only energy source and there is no fossil fuel which is being burnt.